Hey everyone, good afternoon. I'm Rachel Rogers, Product Manager here at 3DXTECH, and I'm actually accompanied by Ezra Scott today. Ezra, you want to introduce yourself?
Yeah, I am the Director of Operations here at 3DXTECH. Been here 8 years and been in the additive industry 13 years.
Which is impressive because additive is a relatively new technology and industry, as most people know. So I've been meddling with 3D printing for about 10 years. So started in high school, which was really fun. It was just a little MakerBot or some little machine, I don't remember what it was, shoved in the corner of a classroom because they got a grant for it, had no idea what to do with it, just kept it there. And I am a big fan of tiny technology, and that thing was small. So I latched onto that. Well, it was a CNC class.
Yeah.
It was a CNC programming class. I would rather deal with the thing I can pick up and carry than the 3-ton piece of equipment that I have no idea how to run and costs $1 million if you break it. So printed a couple things on that, designed a couple things in CAD. That was my first experience in CAD, and then fell in love with it. Went to college for product development, and then crazy set of situations and experiences, and here I am.
Nice.
Yeah.
Yeah, sadly I avoided 3D printing when I was in middle school and high school. I was exposed to it in a tech center, and there was a really nice printer there. It may have been a Stratasys.
Really?
And I don't remember the exact model, but it was in the corner of the room, and I know it was a lot of money, and they were like, don't touch this thing, only the design students get, students get to use it. And I stared at it, I'm like, huh, interesting. Parts don't look that great, I don't care.
Oh my God.
And then little did I know I was gonna get hooked completely into it in college. So.
Yeah, here you are.
Yeah.
Very nice. Yeah, so just wanted to get a little video about kind of recapping what we saw at RAPID, what we enjoyed, conversations we had, just keeping up to date in the industry, and then kind of how that relates to what we're doing here. So I think, first off, probably my favorite trade show I've ever been to.
Yeah.
So RAPID obviously is something that we've been going to for a while.
Yep.
I've only been there twice, I'll be honest, but in Boston, just different energy.
Yeah.
Different energy in the industry. I don't know if it was industry specific, if it was because of the location change or what.
I think it was location.
Yeah, just brought some new life into that trade show, which is great.
Yeah.
So don't get me wrong. Love it being in our home state of Michigan, in Detroit, most years, every other year. So, but just having it in a new place, especially such a big city like Boston, was something really special.
Yep. Really liked the energy. There was a lot more aerospace customers there.
Oh, yeah.
That seemed to be more local and were stopping in for day trips. So that was exciting to see. Just a lot more energy coming back into the space because shows previous had felt like there was a lot of change, and this one felt more stable. Yeah,
yeah, it was really cool. Obviously, I was at the booth for the entire time, answering questions for customers that approached. So I didn't get to see too much of what was actually going on at the different booths, but people actually did come from different booths, which was great. There's a lot of chatting happening between competitors, between different aspects of the industry, which was great. Had a lot of conversations with like printer suppliers. 3D scanning was a big thing that was talked about a lot, for a good reason. I think that has pushed some new areas of 3D printing. You don't have to model it from scratch in CAD anymore. You can 3D scan very intricately.
Love that stuff.
Oh, so good. Yeah, I know that's one of your niche interests. So, but it was really cool because a lot of our customers who approached us, I really liked. They felt very direct with a lot of their questions. So in the past, not in a bad way, we've had people come up to us and just ask about the technology as a whole, ask us about our entire portfolio in one question, which is great because I think we have a really cool portfolio and I love talking about it. But having customers who approach us with a very specific application with very specific specifications that they had to hit made it so much easier to have what felt to be an active conversation, like actively moving forward with a project rather than just talking about the theoreticals, which I think is really cool. My inbox has been flooded ever since with continuations of those conversations. So it was really nice to just take it kind of out of the realm of theory and magic and pull it into actual useful technology development.
Yeah. I really liked the new Diamondback nozzles that finally came out. I know they've been getting asked a lot of questions about that, which we are partnered with them, so that was cool to finally see them at the show. that I know is a partnership between Diamondback and E3D, so it was fun to see that, and their giant ice sculpture that they always bring, so that was always
yeah,
fun.
watching the thermodynamics of that is so cool. For reference, anyone who unfortunately was not able to be there, they have a giant ice sculpture, and they have multiple different types of materials, just kind of coins, that they use to show the heat, or I should say cold transfer of those materials. Absence of heat, semantics. But really cool to just feel that difference. That's a really applicable way to show why that technology is so important in 3D printing as a whole, getting that heat transfer so that your polymer fully melts, actually gets good layer adhesion because it's fully liquid rather than some semi-crystalline, semi-amorphous gobbledygook. So really cool to see that. The effort that vendors put into those booths, I think is really cool. And shout out to our marketing guys for making a really cool booth. Having an entire car engine in there
that was an exciting topic at the show.
That drew a lot of attention for good reason. So, and shout out to the garage shop for that, because that thing was a monster. It caught a lot of attention, started a lot of really good conversations.
So it was a work of art, and you don't see those things very often because those engines are so expensive.
Yeah, and it was a labor of love for sure. And the fact that we got to participate in that with some 3D printed prototype parts and end-use parts, it's a really unique experience. So really shows off some of our high-temp materials, which is what we do best.
Which, speaking of high-temp, Big Rap's booth, awesome.
Oh yeah.
They were obviously printing with some of our materials, so that was cool to see, and then we announced our partnership with them as well. So very, very cool to see them continue to progress into the high temp space, which there's not many printer manufacturers out there right now. So really, really nice to see that expansion into that space.
Yeah, I love being able to partner with different companies, because as open source, we want to support as many different platforms as possible. I think it's really important, especially tailoring to the different specialty materials that we offer, finding companies that can really utilize it to its fullest extent, I think is so important, and not limit any of our customers. Give everybody a range based on their budget and their needs and their workshop space that they have. I know some of us are shoved into the corner of a garage, so really fun to just open up those capabilities for people that feel like they need a little bit more than what they have right now. So, and really cool guys. Very cool company. They care a lot, and they are very tech focused, which is great, because I feel like when you get into some of our more specialty materials, that's what you need. You need a lot of understanding of the delicate nature of a lot of these materials. So but yeah, I think Rapid was fantastic.
It was.
Other than the engine, I think the thing that generated the most hype was probably our PEBA basketball.
I think so. I would say that was second to it.
Yeah, 100%. I don't think that thing sat on the table for more than 15 minutes at a time before it was in somebody else's hands getting bounced around. So huge, just on that note, shout out to everybody who showed up to our booth. That was great. Turnout was amazing. Conversations were fantastic. The people who just came up to tell us how much they loved our materials, that keeps us going.
It does.
It really does. We want feedback in all forms. We always want to be improving, but just having someone come up and say, I rely on your material over any other company, just really reinforces why we do what we do. So, and PEBA basketball, a lot of you guys asked if you could bounce it. That's what it's there for. It was, we would not bring something that couldn't be used, other than the flute. We're not allowed to use the flute, so.
It's too delicate.
Yeah, but it's a health hazard. But yeah, PEBA, I think, was one of the biggest ones that I was excited about personally. I feel like it's a really novel product. 3DXLabs focused, obviously, because it's still in development. So I'm really excited. I think PEBA is my biggest one that I'm excited about. Just that the fact that it's a elastomer, which there's not a ton of availability and variety in the industry right now, and I think there should be. Obviously limited by some printer technology right now. Get a little bit funky when you get to those lower durometers, but the benefits of it, I think, is really huge, especially in applications like drones or gaskets, fixtures, things like that. Impact absorption is huge, and I think PEBA is going to be a huge benefit for that.
Yeah, and a lot of printers now are starting to pick that up and change their design to be able to accommodate the flexibles. So it's nice to see that. We obviously have had to make some modifications to our printers, but the manufacturers are catching up and adding additional features to be able to accommodate that. So
honestly, I think elastomers could be one of the big things now. I think it's on the horizon. So definitely.
Let's say, I'm trying to think the most common questions that were asked at the show. I mean, we had a lot a lot of questions there, but there is a good amount of military, aerospace, automotive even, just a good range there. And I do think a lot of that was just because Boston is a different location, and so there was a lot of new, shouldn't say new, companies that we normally don't see because of the location. So.
Oh, absolutely. Yeah, and like you said, those questions were great. I got some that definitely stumped me.
Yeah.
Always learning, always improving. So definitely some that I had to follow up on email once I looked up some of the regulatory documentation or specifications from our suppliers and compounders. So, which was really fun. But yeah, I think, just constantly learning, I think is the big thing that's driven a lot of our 3DXLabs materials now. So I'm excited. I don't know about you. I've learned so much about so many different material types and applications for those. We've had customers come to us and ask about specific materials that we've used to drive those 3DXLabs conversations and potential launches. And then we've also just had like your automotive work. You do a lot of automotive work, and that's driven a lot of our desire to delve into some of the material families that otherwise have not been touched by additive yet. So I think the industry needs to really drive into the automotive aspect, because that is what drove a lot of the development of the industry in the first place. And I think there's a lot of areas, especially with the cost reduction, that automotive's always trying to do, particularly in like prototyping phases. I don't see why we wouldn't want to accommodate some of those same material types. Having the same material in prototype that you're going to have in final part is vital for a lot of these functions.
Which, speaking of that, FRPC, great material example for that. CTI, so the electrical resistance rating of materials, isn't really commonly talked about, and that's something, even though EVs have gone up and down on the market, it will continue to rise because the technology is very efficient and convenient to be able to just recharge, and just like power tools, they're continuing to become better and used more widely. Having a material like that has those ratings that you can just print the parts and be able to use it in the world is very exciting, because that's something we didn't have before. Really like that application.
Yeah, FRPC being as insulative as it is insane. That CTI of 600 volts, that's class 0 for anyone who's asking, comparative tracking index. That is basically the ability for it to carry that certain amount of voltage before it starts to get mechanical degradation, before that pure voltage starts to physically wear away at the bonds and the actual chemical structure of that material. So our FRPC is 600 volt rated, which is class 0. That's the best one you can get. So it is specifically EV rated, and I'll do you one back and say PEBA is also rated for 600 volts, which is exciting. So obviously does not have the thermal resistance that FRPC does, hence the FR in that PC. It has additional thermal and flame retardant properties. So, but I think the fact that we're coming out with more products that delve into that side of things, understanding that a lot of applications nowadays are fixtures, tooling, or automotive that does directly touch either high temp areas like engine bays or battery and voltage. Why would you not want some additional protection in those aspects? You want your part to fail based on the FMEA that you're doing at the time. You don't want to have it fail because of some aside, like extra voltage going through because you didn't ground your prototype correctly, something like that. So just having that additional protection is, I think, fantastic.
I think the other one I was excited about was PVDF-GF. So that one's exciting just because we print a lot of PVDF here. A lot of our customers print PVDF. It is a tricky material just due to that high shrink rate, but the chemical resistance is amazing.
So worth it.
But the glass fill is helping a lot with that. So we're seeing great results with the warp and fighting that, and being able to print a lot larger, more complex parts with minimal warp. So that's exciting just because it's a very common material for chemical resistance, and being able to help customers print larger parts of that is awesome to see.
Yeah, no, it's awesome. I'm excited for that one. Some of the parts that we've gotten from our lab has been pretty exciting. So always working to improve that, especially balancing the chemical resistance, wanting to have that inert glass fill rather than carbon fiber. So that's the other aspect too. Carbon fiber does remove some of that insulative property because it does naturally conduct electricity, regardless of if it's in the polymer matrix, so it's more isolated from one another. We don't want to add that liability in, because a lot of people go for PVDF because of the insulative properties. So adding that glass fiber felt like the most natural fit for that. So, and we do have a blog post about carbon fiber versus glass fiber for anyone who wants to know, not just the PVDF, but any other materials we offer, like ABS, our different nylons. You can get a glass fill versus a carbon fiber, and you might want to know why. So, but yeah, I think the PVDF-GF, I'm really excited about that one. I think everyone that we showed it to was really excited about the lack of warp that you could get from it, because they were like, I love the material, I hate the warp. So obviously doesn't mean you can print you know, on a super cheap open
you still need some heat in the chamber, and
but it just helps reinforce some of that dimensional stability a little bit. So the fact that you don't have to dry it's great too. So makes it quick, and it's a really robust material. So I think that's something I'm excited about, is we're getting into some of the more exotic materials that people haven't heard about before. I think the world is a lot bigger than just PEIs, PECs, peaks for high temp, and I think we need to really capitalize on that, really push. Because, you know, those are great all-arounders. The price can be a little bit prohibitive, and a lot of times you don't need every single aspect of the performance. You don't need chemical, thermal, and mechanical. You need one, maybe two of the three. And in that case, I think there's a lot of alternatives that just make more sense for the application, and they're more approachable, which is exciting. So we want to really delve into that mid to high ultra range and just try to make it a little bit easier for customers that want to take the step from base PC but aren't quite ready for peak, because that's a lot. It takes a lot of learning.
I mean, that's exactly what automotive does, right? They're going to pick materials that meet those properties, but try and do it for the most cost-effective.
Some crazy ones. You've shown me some that I don't even, the alloys don't make any sense to me. I don't know how they're chemically compatible, but they did it. So that's something I'm looking forward to as well with like PEBA. Is it so PEBA is used for like sports equipment. They're used for like shoe inserts, shoe soles, and then like skiing, because it has some lower temperature impact resistance as well. It retains a lot of that mechanical property at lower temperatures, which is great. That's over a lot of TPUs. And don't get me started on TPUs, because it upsets me that that is an umbrella term for a huge variety of families.
Sounds like we need more.
Yes, we're looking into that one. Thank you. Nope, we're looking into some additional TPUs and elastomers as a whole, but I think TPUs are so generalized that people don't realize you can get a huge variety of thermal performance, chemical resistance, and then just any focus you want to have on like compression set. Well, there's an entire separate section of TPUs that are really good at compression, maybe horrible at tensile, vice versa. So, whereas PEBA is more of a specific chemical makeup aspect, so it has a little bit more defined box, whereas TPUs are more of that field. So, any statements I make of TPU versus PEBA, you could probably dredge up a TPU grade that does what PEBA does, but I think PEBA's all around. A lot more engineering grade than a lot of the TPUs that are offered, especially in additive. But that's a big thing for me, is that PEBAs are frequently used for overmolding. Now, additives does not overmold like you do with an injection molding process.
But it's not the greatest.
Yes, but it is. It does adhere to some aspects, which so I am excited. I want to go a little crazy and try some dual extrusion of maybe you know, different material like a PE or a nylon, and then try to print over with PEBA. I feel like that would be really cool.
And there's more dual nozzle printers coming out every day, so it's definitely something that I think will grow as people realize there's compatibility amongst the products. So.
I think that's one of my favorite parts of 3DXLabs, is trying to chase that printer market, and in some cases get ahead of the printer market, anticipating what not only our customers want, but then just what we want to see. We really love working in tandem with a lot of our printer suppliers and the manufacturers. Their technology they're coming out with is fantastic, and I really want to just help drive that focus, because I do think additive's changing as a whole. I think it's becoming a lot more focused, and that's really exciting. It's becoming more, hey, we're not going to pretend that these machines can do everything.
They can't do everything,
no, that's not realistic. There's a reason why there's 18 different plastics manufacturing processes. 18 is a random number, but there's a reason why. Because you can't do, it doesn't make sense to make a chair with injection molding. at least not as a full assembly. Like you want to go for roto molding with things like that, or tubing wouldn't be injection molded. You have to extrusion mold that.
Yep.
I think 3D printing needs to become the same thing, more on the materials side of things. But it's great when there's a printer that can do it all.
Right.
But that's few and far in between, and a lot of times the cost is not worth it for our customers. So.
Yep. And you have to factor in the Z-strength issues that a lot of materials have, which thankfully a lot of the flexible materials don't have that issue. There's a lot more strength in the Z direction, but most other polymers do have that issue where you're not going to get an even test in all directions. So.
Which is why we test different orientations on our parts now.
Right.
So really want to drive that in for the technical data for our customers. We want to give them as much information as we can give. So we test our tensile bars in 3 different orientations. We test them vertical, flat, and edge. So you can really get an idea of, hey, how I orient this part is going to drastically impact that mechanical performance, or not so much, depending on the layer adhesion that you get. So, yeah, I think that's exciting too.
Yeah.
Man, I'm trying to think of, I do honestly, I'm very biased toward PEBA because I think it's a fun material. I know I keep bringing it up. But I think it's a really fun material, and I think it really shows where we want to take 3DXLabs as a whole. We want to try out the crazy stuff. And we want you guys to be able to try it out too. Tell us what you think, because anything that we sell through 3DXLabs is not in its final phase. We are always open to feedback, especially we don't have every type of printer on the market, you know? So I think a big thing for us is having our customers who have a variety of printers and a variety of applications try it, see if they like it. If not, we want to hear why. We would love to know why. It helps us develop print profiles for it, helps us understand the material better, helps us in our manufacturing process as well. And then if we ever have one that fails, cool, we'll go back to the drawing board and we'll try again. So, yeah, we always want it to be a customer-driven process. We always want it to, because at the end of the day, we're making material for you guys to do your crazy things that you dream of doing. We just want to enable you to make it, which is really cool.
So PEBA is your favorite 3DXLabs material then?
So far. So far. We have a couple more coming up that I think will be really exciting. So
okay.
I'm not going to tell you any more. So I'm getting glared at right now from behind the camera. So we're not going to tell you any more about any of those. But
no one's allowed to know.
No one. I don't even know sometimes. So, but no, I
feel like we're missing one of the materials that we showed off at the show.
Actually, we're missing a few.
Yeah. Oh, okay.
We've only talked about a few.
Yeah,
now,
I was going to say there's
2 of them are not going to be in the 3DXLabs portfolio.
They're very big
We're
products.
going to introduce those directly into our active portfolio.
3DXLabs
wise, HT-PETG is one that we're also releasing. So I think that one is really nice because it's just a baby step off of what is otherwise a commodity material. So it's for people who are ready to delve into some higher use applications, maybe want to make a part that's not a prototype for the first time. They want it to be an end use part, or at the very least a more destructive use part. They want to actually push their application to the limits and not have a part that's going to fail halfway through your cycle. Which I think is great. So that one, go ahead.
I was going to say, I would compare it more to like an ABS, but you get the UV resistance that ABS doesn't have. But it's still a little bit tricky to print. It's very similar to ABS with its print settings. But thankfully, there's so many printers out now that can print with a heated chamber and higher nozzle temperatures. So you're going to get the ABS-like properties, but you will at least have some more advantages where you can have a clear material, or I should say mostly clear, because it is slightly smoky naturally, but the UV resistance is also nice because ABS is not going to get you that.
Yeah, 100%. From what I've seen in our print so far, there has been less warp generally than you would get with ABS. Still a little tricky, but not too bad. And then, like you said, that light transference has been great. We've been optimizing our print profiles to get a really good balance of that layer adhesion, but also get good light transference in it. Because when you get to a certain level of heat, so you're going to get some more smokiness, you're going to get more glossiness, which is really cool to see. I think that's a really good real-life reinforcement of how polymers react to different temperatures in your printers and how it can change not only the visual but also the mechanical aspect. But and then obviously that HDT is 100C rather than PETGs. I think it's typically 70 to 80 C.
Yeah, right around 80.
So you're bumping up, which I think is good. And it's going to be more economical than, say, jumping to a PC.
Right.
So I think that that's going to get people a lot further in their applications when you don't feel like it's justified to buy a $100 reel material.
Yep.
You just need something that's better than our commodity materials, a little bit more engineering focused, and gets good all-around performance without really breaking the bank.
Yep. Now those other two that we showed off are very exciting because one of them, 3DXTECH has had an ESD nylon in the past, but it's been a while, and we're bringing it back. But we're bringing it back.
It's been a while.
Yeah, it's been a while.
Yeah,
it's been well over a year.
Yep.
I think I can confidently say that.
Yep.
But we're bringing it back in a different form,
Yep.
and the form is also compatible with a very popular machine out there, or I should say, a group of machines.
Yep.
So.
Yep.
That's an exciting one.
Yeah, so that is Obsidian. Woo! So we, as people probably know, we have a nylon that is called Obsidian. That's our product line that is meant to be compatible with Mark Forged printers and compete with Mark Forged materials. So that would be the Onyx alternative. And with that one, it's always been a standalone product, and it has been so well received, especially this V2 that we revamped. We heard customer feedback. We decided it wasn't what we wanted it to be. Made a V2. It's been great. The feedback we've gotten is phenomenal, and so we decided, hey, so many people use this. There's a lot of people who also need the niche versions that Mark Forged makes, which is Onyx FR and Onyx ESD.
Yep.
And so we wanted to compete in that space as well. So we are going from a standalone product to a line, Obsidian line, which is really exciting. So as Ezra mentioned, ESD Obsidian is a big one. So that one obviously is static dissipative nylon, which is great. You get the chemical resistance of nylon, you get the flexibility of nylon, because oh boy is Obsidian flexible. Woof, it's flexible. It's, people at the booth were shocked at the fact that you could take a test bar and pretty much make it into a bracelet.
Yeah.
Didn't see any sort of deformation lines or permanent deformation.
Great layer bonding.
Oh, fantastic.
A really nice HDT, right around 145, right?
About, yep.
So you can get high use temp, or I should say higher use temp, and you still get nice flexibility out of the product as well.
I mean, you use it in your personal applications, so which is great. And you push those things to the limit.
Yep.
You do not stop at that HT2.
They're very useful for car parts. So that temperature resistance and flexibility that you get from the nylon makes it a very durable part. There's great layer bonding. So all of those things work really well for automotive underhood applications.
Yeah, especially that ductile failure,
Yeah.
I think is huge. You don't want brittle failure in a lot of those applications. And Obsidian really fits the bill on that. So, and then, we decided we wanted to do a static dissipative version. So just getting that extra static dissipation so you can protect your electronics for something that you need more robustness and flexibility than you say if you did our ESD PLA.
Yep.
So something that's going to see more heat, it's going to see more like compression or tensile, anything that you just need. You need a brick of a material that's also going to protect your electronics components, or at the very least just not short out any of your systems down the line. And then FR Obsidian, I think, is the one I'm the most excited about, just because flame retardant nylon, awesome.
Right.
And we did get it tested to UL 94 standard, and it is V0 at 3 millimeter thickness, which is fantastic.
Right.
So that is pretty awesome. We went beyond the UL 94 outside of our shop and just held a torch to it for...
It was a lot of fun.
Probably too long. It stood upwind, but the fact that it just didn't burn, it charred, and the char was persistent, which was great too. So that's something a lot of people don't think about when they comes to flame retardant materials. Not only do you want it to self-extinguish, you do not want it to leave piles of ash left behind, because if you're in an assembly or like an engine bay, let's say, that can cause issues too. Getting ash and other particulates into the rest of your system can be detrimental. So the fact that we made something that has that finished char, almost like a rust, it sticks to that surface, I think is very important. So we're excited about it.
Yeah, and they're all nylon 6 based, so obviously very thirsty materials.
Yep.
So our previous ESD nylon was an ESD nylon 12.
Yep.
So this version's a 6. Maybe we should probably talk about that a little bit, right? 6 is a lot more prone to absorbing moisture. Obviously, the higher use temp, though, does help it. So if you're at that higher temperatures, you really don't have to worry about the moisture. But compared to the 12, there is a lot more moisture absorption. Trying to think what percent. It's multiple percent that it can absorb. So that is one thing to note, is that as the material stabilizes to the environment that it's in, it's going to become more flexible because the water will make it a lot more, trying to think how to describe that.
I always say it's lubricated by the water, to be honest. I know it sounds dumb, but when you get into that like macro molecular discussion, it really does, when you talk about water in polymer chains, it does become, you can use simple metaphors. You can use metaphors like ice and cracks where it will expand it. You can talk about the fact that water kind of lubricates those polymer chains between each other. So for anyone who doesn't know, polymers, the chains are not chemically bonded, so there's no electrons that are shared between two atoms, anything like that, other than that's what's the difference between thermoplastics and thermosets. And I'm going to stop there because I'm going to get too far into it. But so polymer chains basically just have intramolecular forces, so kind of its own little gravity between each other. But so they can slip. If you have enough force, you can slip. That's where that elongation comes from in tensile bars. So with nylon specifically, when you get that water in there, it allows for more flexibility. It allows to kind of buffer and pillow those chains. It does allow for a little bit more slippage of the chain, so you see slightly more creep over time, but all nylons are going to hit equilibrium in the environment that you set them in anyway, so typically that creep resistance and everything is accounted for in any data that you find.
Right.
So really cool. I could go on about that all day, but yeah, the fact that it's a nylon 6, I think in a lot of cases is a benefit. It's just making sure that it's dry during printing, I think, is the biggest thing, and accounting for a little bit of swelling in final application. So
speaking of elongation, PEBA.
Yes, PEBA has so much. It's, I believe, 550% plus.
Right. Which is much higher than most TPU.
It is a lot higher than
materials.
most TPUs. When you get into like the 70, 85A range of those TPUs, you get 600 to 700% elongation. But the thing I like about PEBA, if anyone saw the basketball, I keep referencing that. I'm sorry for anyone who missed out on it. But with the basketball, you have a very strong structure. It's very geometry based, which is exciting, which I nerd out because I am product design development as my educational background. So the idea of printing like a shoe sole that has variable thickness and wall thickness and infill and just geometric patterns and webbing inside of it to change the amount of energy rebound in the different sections of the foot is so exciting to me. And I think that's a huge driver, and that's where that elongation comes from. So
and the fact that a 90A can do that is exciting.
People were shocked when we said it was just 90A, because when you have enough infill there and enough structure, it feels a lot harder. Obviously, that surface hardness doesn't change. That's a material characteristic. But the structure and the strength is greatly variable based on what you do for print settings and then also your actual design, which is exciting. So I think that's something that I really love educating people on, is anytime you are making something with additive, it is not just one of the three variables. It's not just design or just printer or just material. It is a symphony of all three. And you really have to balance those. That's why, you know, sometimes I have to answer people when we're having applications questions and say, I think this is a good starting point for you. You're going to have to test it on your own, because we can't accommodate for every single variable that comes from those three, which is exciting. It's exciting. There's so much learning opportunity in industry. And I think people just need to be brave and be bold and try and fail as much as you can within your budget, and just work to figure it out. I think that learning aspect of this is so great. Plastics are cool.
They are.
I'm always learning more about plastics.
There's so many plastics out there and so many different varieties of them.
Oh my gosh. Yeah, the different additives, let alone different grades and different chemical structures of different grades, like the alloys. We won't even get into alloys. Those scare me. But I think it's so cool. Just that difference that you can get there is really fantastic. If I go any deeper into any of these topics, I am going to be talking for literal hours. So, which I'm not opposed to doing. But it'll be excessive. So I think we're going to probably wrap it up here. Again, thank you to everyone who came by for Rapid. It was a joy to see you. We love getting outside of our little sphere and just getting to see people from all backgrounds, all different areas, all different companies, industries. Just excitement across the board has been so fun. And love getting to talk to you guys about crazy new stuff that we're doing. So
I was very excited to put a lot of faces to the names. So it was really cool to see our customers, a lot of them actually brought parts to the show, so it was very exciting to see them, hold them, and know exactly what they're doing with our materials, and even give feedback on that. So that's definitely something that we are extremely passionate about, and hopefully that shows through the camera. That I cannot get enough of it, so obviously continue to send things our way because we love it.
Yeah, absolutely. And so again, thank you guys. Thank you for listening to our crazy tangents about these things. Get excited about 3DXLabs because I know I am, and we're going to have a lot more stuff released in the relatively near future. Yep. So I think there'll be something for everybody, hopefully. Let me know if not, because I'm always up for making some more stuff. But anyway, I'm Rachel Rogers, Product Manager at 3DXTECH. This is Ezra Scott, Director of Operations at 3DXTECH. And I think that is it for today. Bye, guys.